Hello. So some people were asking me to do a small tutorial on how we can improve the experience, the quality of life for the VR spectators that are looking at what you're experiencing in VR on their screens. What I mean by that is if I press play right now and I start looking around, you can see that as long as I'm moving quite slowly, it's fine. But the moment I start really kind of looking around as I would normally, let me just jump right here outside, take a look at this, this structure, the structure moves as well, and I'm looking at the gears at the top, and so on. It becomes very jittery, right? And that jitter is, while for me it's quite normal, for my eyes when I have the headset on, for the viewer it's a little bit too shaky. So in this tutorial what we're going to do is we're going to smooth out that experience, right? And before we begin, you need to understand that there are two main actors involved in giving you the experience into the headset, through the headset. Generally speaking, the player character, the VR player character, and the second one is the VR, how is it called? I want to do a proper VR camera, spectator camera, something like that. Let me just spectator, blueprint VR spectator, and those are just default blueprints that come in with the Unreal Engine 5 VR template, right? So first of all, and this is how the VR spectator looks like, and our VR pawn, the player character, is actually not present here. Instead, we're using player start blueprint or node right here. So that's the first thing that I do is I fish both of them out and open them up. So you can find your VR template. You can find your VR pawn under your VR template folder, under blueprints, VR pawn, right here. Double click on it, and it's going to open up the whole chain of logic of how the VR character, the pawn that you control, how it should behave and what kind of actions can it make. And if you want to nerd out about it, you can just kind of read through all of these and try to get a sense of it. But in our case, we don't really care. The only reason why I'm showing it to you is right here. I feel like this is an important setting. This is where, right at the event begin play, connected to that, you can control the pixel density that is produced by the headset into your eyes, right? So you can drop down the quality like so, and thus increase the frame rate. So if you feel like the 3D model that you're previewing is too slow and it's all jagged and messy, consider dropping down the pixel density a little bit. Anything below 0.6 is a little bit too blurry, but 0.8 seems to be holding up just fine. If you want to, you can also increase the pixel density, but I wouldn't recommend it. It becomes very expensive very fast. Anyway, so in terms of VR pawn, the character itself, we will not be doing anything with it. Instead, what we will be using is VR spectator blueprint, right? So under VR spectator, here you have the blueprint class, but also if you have started with the VR template, you will have the VR spectator camera right here, somewhere in the scene, right? So you can select it, and then here on the top right corner you can click on edit VR spectator. So that is going to navigate you to the blueprint of VR spectator automatically. Then in our event graph right here, this is where we can set up different ways of how you can spectate, the things that the user sees, right? So we will be creating our blueprint right here. So the first thing that we need to do here is to assign a key that you press to dampen the spectator camera, right? And I think, okay, so there are two systems of how we can do it. We can do it brute forced, right? just straight up we assign a key in this template right here, or in this blueprint right here, and we use it, or we can do through the enhanced input action system. I think for this tutorial, since we're using, since it's focused on the dampening portion rather than the input actions, we will be using the simplified, the brute force way, or I should say probably the old school way. So the way we do this is, first of all, during begin play, we need to enable the VR spectator blueprint to receive inputs, or to generate rather, sorry, to generate inputs, right? So for where you have begin play tab right here, the last node at the chain should be enable, sorry, things are in the way, enable input. There we go, right? Target is self, player controller. I think as long we can just keep it default, it's going to it's just going to work. This makes it so that you can press keys and keys will do things in VR spectator blueprint. Speaking of keys, now we can decide on which key to press, right? So we can do key, is it event key, key event, keyboard event, and you can scroll through this and use, you know, find any key that you want. Honestly, the faster way is just to select any key, select the node here, and on the top right corner where you see input key, just click on the little keyboard and then just press any key that you want to use to drive the change in the dampening versus not dampened, or soft camera versus not soft camera, right? So I'll press the asterisk, I guess. So now you can see numpad asterisk is going to be the one that changes my dampened camera. And then I will probably create a new variable on the bottom left hand side under variables. Click on the little plus sign here, so to create a new variable, and choose follow damped, like that. It should be a boolean variable. Yeah, it's either yes or no. You are either following with the damped camera or you're not. And when you press the asterisk key once, it should set, so you just drag in follow damped from bottom left to the screen, set follow damped, it should be tick marked, so it's going to be following. But when you press it again, I will drag it out again, set follow damped, it should be unticked, so it's not following, right? So you press the key once, it follows softly. You press the key again, it doesn't follow. A tool that does that is called flip-flop. Flip-flop, like that. A connects to setting it to true, B connects it to setting it to false. That's it. C, select everything, press C to comment, and you can write it toggle follow or something like that, you know, just to keep things clean. Okay, with that done, now we can place the following under a tick. So right next to begin play, right under begin play, there's the event tick that happens at every frame. Let's say frame, it's not really, but let's say every frame of the gameplay. And here under these two different modes, either first person mode for spectator or the fly mode for spectator, you can continue on the chain, right? So what we can do is we can create a branch from one of these nodes, doesn't matter which one, and we just connect the second one into the branch as well. So it doesn't matter which one of these nodes is triggered, the branch is still going to be triggered, right? And the condition is it true or false, is going to be our follow damped, right? So get follow damped. I just drag it from bottom left, the variable, drag it, follow damped, bam, the condition is here, right? And right now I guess I can kind of show you. So let's say if it's true, it should print string following, right? If it's false, it should print string not following, like that. This is just for me to show you how it's gonna work, right? So I compile, I click save, here I press play, right? It's doing the thing. It's not working. Oh yeah, because I need to actually click on the button for it to trigger. 1 second. So to check what kind of button you need to press to actually enable this VR Spectator camera, you just need to go to the VR Spectator folder right here, expand it, input, find the input folder, double click on the IMC VR Spectator, this one right here, the input mapping controls, I think. And here under mappings, you expand mappings, you check IA VR Spectator toggle, expand that, and here you can see that it's set to tab. I think tab is the default, right? So tab will change the from the headset display to the VR Spectator display. That is useful information, right? So if I press play now, this is the VR headset being shown, but then if I press tab, you can see that's the Spectator camera, which is not following. And by the way, the cool thing is that I can now wait, let's see if this will work. I can stand where is it? Up. I can stand in front and I can wave, right? So before we were seeing the view through the headset, and now we're seeing the view through this camera, right? And if I press the asterisk, it's not printing not following right now, but if I press it, it's now following, right? Not following, following. Okay, so the functionality is there. It all works. All we need to do right now is with the VR Spectator function, instead of using print string, we can delete this. We need to, when it needs to follow, true needs to, when this is true, the camera needs to be placed on the head of the viewer, and it needs to be placed smoothly, right? So it needs to interpolate between the movements of the head smoothly. So the way we do it is we get all actors of class, and our class that we want to get is the VR pawn, the player character, right? VR pawn, like that, VR pawn. Then out of all of the actors, I mean, we're getting only one, right? There's only one VR pawn that we have, so we will get a copy. So we're getting the only one, because this is like a list. We don't need a list, we need a single one, so we use get to get a single one. And we get the HMD, I think it's called HMD. Get HMD data, right? Head mounted display, by the way, HMD. We do that. It seems like it's that data is a little bit off. Let's not do that. Sorry, weird tutorial, I know. Let's not do that. Instead, let's first of all, for our general actor, for this VR Spectator actor, let's set its translation, where or transformation, where it needs to be and how it needs to be rotated, right? So we will set actor transform, set actor transform. the target itself, right? So the camera itself will be moving, and for transform we will be get actor transform. So find its own transformation and then interpolate to a new transformation, which needs to be where the headset is at and where it's looking at, right? So a tool that does that is called t-interp2. T-interpolate2. T stands for time. So delta time, right? Rather, delta time is the counter, the interpolate speed is the time, right? So we want to soften it by, like, let's say every second it gets an average, so it softens out. So interpolate speed is 1, while delta time, we just get world delta seconds. That's easy. Get world delta seconds, right? So it's just counting and interpolating according to the count. And then and the return value is our new transform. That's also easy. The tricky part is the target, towards where. So, you know, again, the position and the rotation of this headset during gameplay. So the target needs to be get world, get world transform. One second. Not like that. Maybe we do it other way around. So from this VR pawn, we need to get HMD. Well, that's HMD data, but yeah, here, right at the bottom of it, of the list, get HMD. Perfect. Get HMD, and now we get world transform. Like that. And connect that to the target. I just want to get HMD data. I just want to check one thing. Break HMD data. Bam. Yeah, okay, so it does have position and rotation listed here as well, but in this case, it gets the whole transform, the scale as well, even though the scale doesn't matter as much. Anyway, so with this setup, it should work. So the way it works is the camera, the VR Spectator camera will set its actor transformation, so location, rotation, scale. It's going to set its actor transformation by measuring where it is, by measuring where the headset is, and by placing itself to the headset, moving itself to the headset and rotating to the headset slowly over the course of 1 second. After the second, it checks again where the headset is, and it's moving towards that new place again, right? So if I click compile, save, play, hello? My battery is dead. Okay, we can test this out now. So if I press play, right, we're back to the normal environment. But then if I press tab, we can see the VR Spectator camera, but now the asterisk moves us right into here. And the camera itself seems to be previewing everything at a lower quality. That is something that I will need to adjust. But with that being said, if I look around and I move in here, you can see that the camera, the Spectator camera, does catch up quite nicely, right? So that's in principle, that's what I wanted, and that's how it works, right? So that's how you dampen the camera. In terms of the quality, the preview quality, let me take a look into that and see if we can adjust it. Okay, in terms of quality, I'm not sure of how to fix it, but what I managed to dig out is that here in the VR Spectator mode, for the screen capture component 2D, we have our texture target that should be displayed, right? And the texture target is this RT Spectator component, to which if I browse to this asset, there's the render target. Double click on that. And here we have the settings for the preview, right? And basically if I were to change it to RTF RGB A8, sure, sRGB or yeah, whatever, hit save. And if I were to play this, hit tab, now we're looking at it with oh, it's lagging a little bit, but we're looking at it with 8-bit data information or color data information. But still, if I get in here, Lumen just completely breaks. So I guess it might be a limitation of that. I'm not sure. So if anyone of you out there knows how to get a consistent throughput from what we see like that and what we see like that, that would be very much appreciated. Because with that being said, if I were to go outside, let me just quickly like that, go in here, and I were to hit tab and we follow in, you know, this seems to be fine. Let's hit tab. So this is what my headset sees, and this is what is displayed in the VR preview or VR Spectator by the VR Spectator camera, right? This is fine. It's just basically Lumen and indirect illumination that's breaking. So again, if anyone knows how to fix that portion, very much appreciated. Leave a comment. If you want to experiment by yourselves with this file, I will leave it for Patreon supporters. Just like every other file, Patreon supporters get everything we do on this channel for free. So again, link in the video description below. And thanks for watching. Now you have a smooth experience. I'll see you in the next one. Bye.